Hi everyone, welcome back to the last in the series of metrology lectures, and today we're going to be looking at least measurable methods for measuring liquids. So we're going to use this example to demonstrate how we use this concept. You would have been familiar with this example from the aliquot method, and so we are going to use the same example to demonstrate least measurable method. A formula calls for 0.5 milliliters of potent drug X. The pharmacist only has available 10 milliliters measuring cylinder graduated in 1 milliliter divisions. Explain how you would advise her to measure the required volume. First thing we're going to do is to determine the quantity of ingredient requested, and that's given to us in the formula. 0.5 milliliters of drug X. The next step is to determine the least measurable quantity for a 10 ml measuring cylinder. Again, we know how to determine this. If it is 20% of the capacity of the measuring device, and the capacity of the measuring device is 10 mils, so 20% of 10 mils is going to be 2 mils. So this means that we can't weigh anything less than 2 mils using this measuring device without attracting a very high percentage error. So therefore, we can only measure 2 mils and above. Of course, 10 being the maximum. Step 3 is to determine the aliquot of a concentrated triturate mixture that will contain 0.5 mils of the drug. This is where we are going to make a statement. We are going to determine what volume of the mixture will contain the 0.5 mils of the potent drug. So we're going to say let 0.5 mils of the drug be contained in 2 mils of the triturate. Again, I'd like to reiterate that we can make this 0.5 mils be in another volume other than 2 mils. Of course, it must be greater than 2 mils. We can make it be in 3 mils or 4 mils. But of course, it is all dependent on a number of things, which we will not get into here. So we decided to use 2 mils to be the aliquot volume. So the next step is to select the amount of drug to be measured, and we usually use the least measurable quantity. That is why the method is called least measurable. So the least measurable quantity for this 10 ml measuring cylinder is 2 mils. So it means then that we are going to actually measure 2 mils of the active drug. Note that the amount of drug to be measured need not be the least measurable quantity, but an amount that will maintain the acceptable range of accuracy and precision. That is, it can be greater than least measurable quantity, and sometimes this is required. But as I said, if we want to maintain the least measurable, then we're going to measure the least measurable amount. And we had discussed this earlier in least measurable quantity, with regards to the whole issue of economics and how economical it will be for the patient if you are going to be charging them. Step 5 is to determine the total amount of triturate mixture to be made, and the triturate mixture is going to contain the actual amount of drug that you're going to measure plus a certain amount of diluent. You're going to mix those two together to get your total triturate mixture. So in order to determine that, we use ratio and proportion. If 0.5 ml of active drug is contained in 2 ml of the liquid triturate mixture, then 2 mils of the active drug that we can measure will then be contained in X. And cross-multiplying, we see that the total liquid triturate mixture will be 8 mils. Then, in order for us to get the 8 mils, we must mix 2 mils with a certain amount of diluent. So therefore, we need to determine what that diluent is. So because we have 2 mils of the active drug that we measured that will be a part of this 8 mils, we subtract that from 8 mils to get 6 mils, and that will be the amount of diluent that we will need to add. How do we determine the amount of triturate mixture that will contain the amount of drug requested? We don't have to do any calculation because we made a statement from step 3. We decided that 0.5 mils of the drug will be contained in 2 mils of the liquid triturate mixture. So therefore, our new formula is going to be drug X 2 mils and the diluent is 6 mils. Of course, another way of writing the new formula could be drug X 2 mils and diluent QSAD 8 mils. So we will mix 2 mils of drug X and 6 mils of diluent, mix them together, and then remove from that resulting mixture 2 mils that will contain 0.5 mils of the drug. So this means that we are now going to be mixing 2 mils of drug X with 6 mils of diluent to form a homogeneous mixture. And from that liquid mixture, we're going to remove an aliquot of 2 mils that will contain the 0.5 mils of drug X. Of course, when we're making any triturate, whether it be a solid or a liquid, we find the concentration, which is 2 mils over 8 mils times 100%, which gives us 25%. So it means then, if you're going to be making a 25% volume in volume solution, you will be able to, depending on the volume you're making, obviously you're making 8 mils, you will be able to remove 2 mils of that 8 mils to get 0.5 mils of drug X. Or another way of saying it would be that every 2 mils will contain 0.5 mils. Thank you so very much for your attention, and I hope that these concepts will help you when you're doing other calculations. Have a great day.